Okay, so you are again welcome to the lesson 7, which is still on frequency count, but this time around frequency count for more than one variables. All right. So this is where we use cross-tabulation of our data set. Okay, very good. All right. So the by the end of this lesson, you should be able to explain the concept and purpose of cross-tabulation. And this is where we actually do what they call the chi-square. So you should be able to generate and interpret cross-tabulated frequency tables in SPSS. And you should be able to compute simple chi-square test. But this one, we have two types of chi-square. We have chi-square test of association, and then we have chi-square test of significance, right? Or something like that. Test of goodness of fit. Chi-square
Mhm.
test of goodness of fit. So we have chi-square test of association, then we have chi-square goodness of fit. So test of association is when you want to know whether two categorical variables are dependent or independent of each other. So use chi-square test of association. You want to know whether two categorical variables they are related. All right. So you should be able to interpret chi-square table, and you should be able to apply these techniques in authentic educational settings. So let's get started. So again, frequency count for multiple variables involve comparing how the categories of one variable relate to another. So, for instance, how does ICT usage differ by gender? Okay, how does it differ? Is there a relationship between school type and student achievement? So, such analysis allow researchers to observe patterns of association and relationship between categorical variables. Abdurazak, you are drawing on the screen. Maybe you should stop that. So I will kick you out. So gender, look at this example. We have gender male and female. We have how often they use ICT, sometimes rarely or often. So here you can use cross tabulation to do this. So you can go to crosstab. It will help you as a researcher to examine relationship between the categories. It can also help you to identify patterns and trend in educational data. It can help you to test hypothesis of association between two categorical variables. It can help you to summarize complex relationships in table form, and you can make some decision out of it. All right. So in this particular example, we'll be using teacher ICT use. We have this data set before, so we just open it and then we do some nice things about it. So to do that, we go back to our SPSS. All right. I have a lot of things open now. Maybe I should close some of them like this. You can go. The data set we used to demonstrate, so you can go. Then what other thing I can let go? This is on the fine, so I can let it go too. So this can go. I don't want to save. Then what again I can let go? I can let go of maybe this text score. Perhaps we don't use it again. So this one too can go. Then I have this. I can still leave this. Then I can now open teacher ICT use. To do that, you go to file, open, then data. All right, click on data. Then you come to teacher ICT file. Look at it here. We have used the set before. You have it already. Then it comes off. So you have it here. You have gender. You have ICT use. You can know what you code. One for male, two for females. Then you have one for often, two for one for rarely, two for sometimes, and then three for often. This is ordinal. I want to make it ordinal because it's categorical, right? And at the same time, often is far better than what? Rarely. So in this case, somebody asked about this question the last time. So we say it is what? Ordinal. Then the school type must be nominal because you just identify which school do you belong. Do you go to public school or you go to private school? So it's nominal, identification purpose. All right. Let me check. I saw some comments here. Maybe something is there. Okay. Yeah, you enter the demographic one by one, or you do it one by one in Excel, then you import to SPSS. All these data set they are entered one by one. Everything here one by one, and this is data entry. This is a different package if you're analyzing your data. Okay, if you meet a data scientist to analyze for you or you're analyzing for yourself, a separate package is data entry. You enter your data, then you make it ready for analysis. We mentioned this at the beginning of this course when we are preparing our data for analysis. So this is data entry. It's a separate thing. You have to do that one after the other, except if you use online survey. If you use online survey, then data entry is so seamless because as you are downloading from whatever thing you use, whether you use Google Form, which is the cheapest and readily available for everybody, you can get your data set out in numeric values. So you don't have to use manual data entry. But if you are using paper and pen questionnaire, you have to enter your data one by one using AND. All right, so this is what we have. We want to do cross-tabulation. Cross-tabulation of what? It says that we should go to descriptive again, cross-tab. We want to tabulate gender against ICT use. Okay, and see what is going to come out. So we come here, again, we go to analyze. All right, we come to analyze, descriptive statistics. Then we come to cross-tabulations. Okay, it says we should put what in where? We put gender in the role and then ICT in the column. Gender in the role, then ICT in the column. You can do some other things there, but for now, let us just okay this. And when you okay this, what do you have? A cross-tabulation of gender and ICT use. I think we just reproduce the table I saw before. There was a table up here. This table, I think we just reproduce it, right? Maybe or maybe not. So, but what we have here is we have gender of the respondent, and then we have ICT use among teachers. Look, this means 10 teachers, 10 male teachers, they said they rarely use ICT. Why 20 said they use it sometimes? And 40 people said, 40 male teachers said they use it often. What about female? 5 females said they use ICT rarely. 15 said they use it sometimes. And 30 female teachers said they use it often. This is cross-tabulation. So you can see you are dealing with how many variables here? 2 variables at a time. Different from simple count of a single variable in the first one we did. So this is the very first thing we look at. All right. So the purpose of cross-tabulation in our research, it helps you to examine the relationship between, I think we mentioned this. And if you want to use, look, we don't have percent. Do we have percent in our output? You can include it. These are output. There is no percentage in this table. You can include it. Come to analyze again, descriptives, then you come to crosstab. Then you come to statistics. Oh, this is where you do chi-square. I don't want you to see this yet. So I think you come to cells. So this is where you have your percentages which you want to include. All right, you include them here, and then you click on OK. Then you have a bigger table. We have produced this before, so we are reproducing it again. So again, what do? You want to use crosstab in syntax. This is syntax. You can just copy this and run it on your own. I've said that we will not be using syntax again throughout this course, but you can use this for your own record, for record purpose. All right, so this is the table where you put the percentages. We just reproduce this now. And then you can interpret the table. Our moderator, please do your job. Somebody is talking, mute the person. Okay, thank you. So in interpreting this table, you have 64.3% of male teachers. Where is the person? Okay, thank you for muting the person. Okay, so in interpreting this table, you have 63%, 64.3% of male teachers use ICT often compared to 40% of female teachers who don't use it often. So you can enjoy yourself with this. Then what about the chi-square? I just showed you just now where chi-square is. You want to know whether gender is related to the use of ICT, okay? Among teachers. You want to know whether gender is related to the use of what? ICT among teachers. Okay. All right, so to do that, we go back to our SPSS data point. Then you come to analyze, right? Then come to descriptive statistics again. Then you come to what? Cross-tabulation, all right? Come to cross-tabulation. Then when you now go to statistics, this is where you see some interesting things. Okay, I want to choose chi-square. All right, I want chi-square now. Chi-square test. So what again I want, maybe some other things there. You can enjoy yourself with them. And this one will give you the some kind of effect size if you want. But for now, we really need a chi-square test. Then you click on, maybe again, these cells, I can remove some things. Chi-square demands for you to have expected values. Maybe I don't need a percentage row and column. I can remove all these things so to have a cleaner table. Then you click on continue and then you say okay. All right, then you have your chi-square table. Okay, and then you have the chi-square test. This table is reproduced first and foremost to see the description of gender against what ICT used among teachers. Then this is the real chi-square table. This output, this one will be in your chapter 4. All right. Now we have the Pearson chi-square. The value is 0.490, and then the asymptotic significance is point what? The p-value. This is your p-value. The p-value is 0.783. If you are using Pearson, 0.783. What about likelihood ratio? This one is suitable when you have a smaller sample size, less than 30. Then again, it is 0.779. What about linear by linear association? It's what? 0.586. You see, each of these, the p-value is greater than 0.05. The p-value is what? Greater than 0.05. That means you fail to reject the null hypothesis, isn't it? You fail to reject the null hypothesis. Then the question now is this: what is the null hypothesis for chi-square test of association? What is the null hypothesis for what? Chi-square test of association. So it means there is no significant difference in the what? In the relationship between the two variables. That's the null hypothesis, or the two variables are not independent. The two variables are what? Are not independent. Okay? Okay? So you retain that. So that means these two variables, they are related, not independent, right? Of each other. Okay? All right. So what again do we choose? So the syntax, if you want to use the syntax to do that, I also put the syntax there. Then let's now go to the output, which we just reproduce this. I think we got exactly the same. So what about the interpretation? P-value 0.783 is greater than 0.05. The difference between male and female ICT usage is not statistically significant. Okay, it's not what? Statistically significant. Although there are some differences in the number of males and females who rarely use, often use, or sometimes use, but that is not statistically significant because the p-value 0.783 is greater than 0.05. Thank you. All right, so with that, we have something interesting to talk about when we are talking about relationship between two categorical variables. Take note, if one of the variables is continuous, then chi-square is not the appropriate statistic to use. Okay? Chi-square is not the appropriate one. If one is continuous, the other is categorical. Okay? Take note of that. But if the two variables are categorical, then you use what? Chi-square. So we have described these row percentages and then column percentages. Is somebody talking? Okay, that's good. What about if we have three variables? Can we do for three variables? The answer is yes. But this must be three categorical variables. And that is what this example is demonstrating. So when you want to know whether gender by ICT and by school type, you can do your crosstab. Okay, you can do your crosstab and then you'll be happy with it. So let's do that now. Since we have the data set and we have the time, we come to analyze again. You come to descriptive statistics, then come to cross-tabulations. You have your gender in a row, no problem. Then you put your school type, you put it here. All right. Then I think I put statistics already. Chi-square is okay. Then you click on OK. Then what do you have? An interesting table here. So you have male and female. Then you have ICT use among the teachers. Okay. This for gender and then ICT use. Then we have the gender and then the school tab, the school type. All right. Then what do you have? You have your, we have this before. We have regenerated gender against ICT use. Then what about the gender against the school type? So we have um, the chi-square test here. What do you see? What do you see? The p-value for all of them is always what? Is greater than 0.05. So that means it is not, again, statistically significant. All right? So the gender does not actually determine whether you belong to public school or private school, as the case may be. Both teachers in private and public school, there is something to talk about. And if you want to do this analysis again using the syntax, you can just copy your syntax, paste it, make sure you select your data, and then you'll be good. What about the best practice in cross-tabulation? Okay, so you need to ensure you have adequate sample size. So this will help you to avoid unreliable chi-square result. Adequate sample size, it means that each cell should have at least 5 expected count. Look, in that output, we have expected count. I think we chose that the last time. Look at it. For male against school type, the count is 34. Expected count is what? 35, 34. Okay? So this is greater than 5. For female, 25, 24, greater than 5. So this, you can now rely on what? On the output of what? Chi-square. And it's given here, 0 cell have expected count less than what? So that means you are good. So you can rely, the minimum expected count you have is what? 24.58. And this is a 2 by 2 table. Very good. So you need to make sure that each cell is not having what? Expected count of less than 5. Then you need to include percentages. This not justify the count. So when you put the percentage, you need to, this will answer your interpretation. So make sure you put percentages. Though it doesn't justify the count, but it is the best practice to put the percentage. It helps you to compare the row column proportions. Then it allows you to report both descriptive and inferential result. So this will help you to provide, the purpose is to provide full analytical insight into your data analysis. With percentages and the count will give you the descriptive part, while chi-square will give you the inferential part. Remember, chi-square is inferential. Okay, then this will also allow you to present both frequency and chi-square value at the same time. You need to avoid over-interpretation. This is just talking about what? Association. Are they related or not? There is no point to say one determines the other or one causes the other. So a significant chi-square value only indicates what? Relationship. They are related. Does not mean they cause each other. All right, then you need to also present your crosstab tables neatly. So this is the place where you can make your presentation in table form, because now chi-square is giving you something or what? On inferential. All right? Very good. So you need to include the total count, so and then you'll be happy with it. So how do you now report chi-square according to APA guideline? A chi-square test of independence. Remember I said there are 2 types of what? Chi-square. Test of independence and then test of goodness of fit. Okay? And you know what is funny? We have already seen test of goodness of fit. We have seen it. And in fact, we have seen 2 of them. The first one is a Kolmogorov-Smirnov. It's a test of goodness of fit. And the second one is what? Shapiro-Wilk. Is a test of goodness of fit. This is how it works. If you can remember the output from Shapiro-Wilk, and let's go back there. This is a very good point to make. Do you have the output here? Let's see that. When we're talking about I don't even talk about this one. It's very important to look at the box plot. Look, when we come here, we look at test of normality. You see, this value you have is chi-square value. This statistic, 0.047, is chi-square value. So Kolmogorov-Smirnov and Shapiro-Wilk, they deal with chi-square value, and the type of chi-square here is chi-square test of goodness of fit. But what we are doing is we have a data set. And then we say math score is normally distributed in the population. So we are comparing our data set with the normal distribution in the population. So we want to know whether our data set fits, look at that word, whether our data set fits the normal distribution in the population. We need a chi-square to tell us whether our data set fit it or not. It's a deterministic test. So if the data set, if the p-value is greater than 0.05, we are happy. Because we retain the hypothesis that says that what our data set is equal to normal distribution. But if it is less, we are not happy. Because by implication, it means our data set is not normally distributed. Can you now see the opposite? In that of test of association, if the p-value is greater, we are not happy. You see it now. If the p-value is greater than 0.05, we are not happy because we are not seeing the relationship we want to see. But if the p-value is less than 0.05, we are happy because we say, oh, we are seeing that relationship which is significant. So take note of that. Goodness of fit, we are happy if we retain the hypothesis. But association, chi-square test of association, we are happy, or maybe we are happier. We are always happy. So we are happier if what? If we reject the null hypothesis. So we are happier there. So take note of that. So so when you are now reporting test of association, you say a chi-square test of independence was performed to examine the relationship between ICT training, allow me please, between ICT training and ICT use among teachers. The result showed a significant association with p-value less than this, and teachers who attend ICT training reported higher levels of ICT use and so on and so forth. This is how you report it if you have what significant result. Okay, then I have some practical tasks here which you can brainstorm among yourself or individually and try to find solutions to this problem. So at this point, I'm going to also pause again. Now, maybe some of you have more questions to ask. So the floor is open. As the floor is opening, I also look at the chat and see one or two comments there which requires my